Unit 5, Day 9 talks about factoring trinomials. So we will be able to factor a trinomial that's in standard form, which is ax squared plus bx plus c. So I want you to think back to what we've been doing. If I ask you to simplify the binomial x plus 3 times the binomial x plus 4, we're going to distribute. So when we distribute, we're using multiplication. X times x is x squared. X times 4 is 4x. 3 times x is 3x. 3 times 4 is positive 12. We're going to combine our like terms, so we get x squared plus 7x plus 12. So if we work backwards and factor x squared plus 7x plus 12, we're going to write two parentheses because we want two things to multiply together to get us back to our original polynomial. We're going to take the first term in each of the binomials, and when we multiply those, they should equal the first term in our trinomial. So x times x multiplies to get us x squared. Then we're going to look at the last two terms in our binomials, and those two terms should multiply to get a positive 12. So the factors we have to get a positive 12 are 1 and 12, 2 and 6, and 3 and 4. So we're going to pick any of those combinations. In this case, we would pick 3 and 4, positive 4, positive 3. And if we check our work to see if we did the problem right, x times x is x squared. X times 4 is positive 4x. 3 times x is positive 3x. 3 times 4 is 12. When we combined our like terms, you can see that these match. So you just factored a trinomial. So let's look at a few more. When we factor, we're going to look for a greatest common factor. So step 1, we always look for a greatest common factor. In example 1, x squared, 4x, and 3 have nothing in common. So after we look for a greatest common factor, we're going to draw our two factors underneath. So we draw our two parentheses. The first two terms in our parentheses need to multiply to equal the first term in our trinomial. So the only thing that multiplies together to get x squared is x times x. So the first two terms in our binomials are x. We then want two numbers that multiply together to get positive 3. So the only factors of 3 are 1 and 3. So we're going to have a positive 1 and a positive 3. Then we need to check our answer to make sure we get our original trinomial. X times x is x squared. X times 3 is 3x. 1 times x is 1x. 1 times 3 is 3. When we combined our like terms, we get x squared plus 4x plus 3. Do not make the mistake and circle the polynomial when you checked it. We are factoring, so I want your factors. So the answer that you need to have written is x plus 1 times x plus 3. Those are the factors, or the two things that multiply together to get our original trinomial. Let's try another one. When we factor 2x squared plus 5x plus 3, what two numbers multiply together to get 2x squared? 1x times 2x. So we'll put 1x and 2x in our first two blanks. What are factors of 3? 1 times 3. So let's put positive 1 and positive 3 into our problem, and then we need to distribute to see if those factors work. So when we take 1x times 2x, we get 2x squared. 1x times 3, we get positive 3x. 1x times 2x, we get positive 2x. 1 times 3, we get positive 3. So our trinomial is 2x squared plus 5x plus 3. So if you make good guesses, you may have to do the problem less times. So 1x plus 1, 2x plus 3 is the factored version of our polynomial. Let's try a couple more examples. So if we are looking for the greatest common factor in 3n squared plus 5n minus 2, we notice that there is nothing we can factor out. So we're going to go straight to our parentheses. The first term in your parentheses multiplies to get 3n squared. So we have 1n times 3n. Then we need two terms that multiply to get negative 2. So if we're looking for a negative 2, we could use negative 1 and 2, or we can use 1 and negative 2. So let's try 1, positive 1, and negative 2. When we distribute this out to check our answer, 1n times 3n is 3n squared. 1n times negative 2 is negative 2n. 1 times 3n is positive 3n. 1 times negative 2 is negative 2. When we combine our like terms, we get 3n squared plus 1n minus 2. You notice that this does not match our original, so we need to choose our second option. So now let's try factoring again. With n, we'll do minus 1 and 3n plus 2. So we need to distribute it out to make sure our factors work. N times 3n is 3n squared. N times 2 is 2n. Negative 1 times 3n is negative 3n. Negative 1 times 2 is negative 2. When we combined our like terms, we get 3n squared minus 1n minus 2. So this, again, does not match our original. So we need to guess again, and in this time, maybe we just switch the location of our negative 1 and our 2. So let's try n plus 2 and 3n minus 1. So we're still using this factor, we're just rearranging it. So n times 3n is 3n squared. N times negative 1 is negative 1n. 2 times 3 is 6n minus 2. When we combine our like terms, we get 3n squared plus 5n minus 2. And you can see that, in fact, these two do match. So the factored form of 3n squared plus 5n minus 2 is n plus 2 times 3n minus 1. So you are guessing and checking and plugging in the factors of your first term, the factors of your last term, and distributing everything out to get the correct answer. Let's try the next one. T squared minus 14t plus 49. Well, what times what gets t squared? T times t. What times what multiplies to get positive 49? 7 and 7. So let's try. So when we distribute this out, t times t is t squared. T times 7 is positive 7t. 7 times t is positive 7t. 7 times 7 is positive 49. When we combine our like terms, we get t squared plus 14t plus 49. Well, we can see that our signs didn't match. What else can we multiply together to get a positive 49, but when we add them together would get a negative? A negative 7 and a negative 7. So let's try that. T minus 7. T minus 7. T times t is t squared. T times negative 7 is negative 7t. Negative 7 times t is negative 7t. Negative 7 times negative 7 is positive 49. When we combine our like terms, we get t squared minus 14t plus 49, which matches our original polynomial. So when we factor that trinomial, the factors are t minus 7 and t minus 7. So let's try a few more examples. If we have x squared plus x minus 12, there is no GCF, so we're going to go straight to our factors. X times x multiply to get x squared. We have 1 and 12 that multiply to get 12. 2 and 6 are 3 and 4. How do we get a negative? Well, one of our signs has to be positive and one of them has to be negative. What should we try? Positive 4, negative 3. When we distribute this out, x times x is x squared. X times negative 3 is negative 3. 4 times x is 4x, and 4 times negative 3 is negative 12. When we combine our like terms, we get x squared plus 1x minus 12. It matches our original, so we know we have the correct factors, which are x plus 4 and x minus 3. Looking at example 6, you can see that we don't have a center term. This time we just have a squared term and a constant. So what I would like you to do is I would like you to write a 0b in place of the middle term. This is so when you're using your guess and check method and you distribute this out, you will see, and it'll be easier to check and see if you get the right answer. So again, our first two terms have to multiply to get b squared. The only things that multiply to get b squared are b times b. Our last terms need to multiply to get negative 16. So in order to get a negative, we need a positive and a negative sign. And what times what is 16? 1 and 16, 2 and 8, 4 and 4. So what do you think we should try? Positive 4 and negative 4. B times b is b squared. B times negative 4 is negative 4b. 4 times b is positive 4b. 4 times negative 4 is negative 16. When we combined our like terms, 4b plus 4b is 0 b's. You can see that this matches our original polynomial. So the factors for b squared minus 16 are b plus 4 and b minus 4. So we have another example. Remember, step 1 when we're factoring is to always look for the GCF. Is there a GCF between 2x squared, negative 12x, and negative 14? These are all divisible by 2. So we'll put our 2 on the outside because it's what we're factoring out. 2x squared divided by 2 is x squared. Negative 12x divided by 2 is negative 6x, and negative 14 divided by 2 is negative 7. Now we want to see, can we factor this further? Whenever you factor out a GCF in front, leave it there. because when you distribute this all back out, you have to get back to your original polynomial, and the inverse of division is multiplication. So now let's factor. What times what is x squared? X times x. What times what is negative 7? So again, to get a negative, our signs have to be a positive and a negative. And it doesn't matter which parenthesis you put those in. The factors of 7 are 1 and 7. So now we just need to put these in the correct place. If we do positive 7, negative 1, when we check this, we get x squared minus 1x plus 7x minus 7. We get a positive 6x. So we need our sign to be negative up here, so we want to go ahead and switch the location of our 7 and our 1. So we're going to write x plus 1, x minus 7. And if we check this, we get x squared minus 7x plus 1x minus 7. Combined our like terms, we get x squared minus 6x minus 7. And if we distribute our 2 back to all of that, we get 2x squared minus 12x minus 14, which you can see matches our original. So the factors are 2 times the quantity of x plus 1 and the quantity of x minus 7. Let's try another one. So there is no GCF between 6x squared, negative 11x, and negative 2. So we want two things that multiply to equal 6x squared. So we have 6x and 1x, we have 3x and 2x. So let's try 6x and 1x. We need two things that multiply to get a negative 2. So we can have a negative 1 and a 2. Or we can have a 1 and a negative 2. So let's try negative 1, positive 2. 6x times 1x is 6x squared. 6x times 2 is positive 12x minus 1x minus 2. Combined our like terms, we get 6x squared plus 11x minus 2. Well, our sign on our 11 is a negative, so I think we need to switch the signs of our 1 and our 2. Let's try 6x plus 1 times 1x minus 2. 6x squared minus 12x plus 1x minus 2. When we combined our like terms, 6x squared minus 11x minus 2 matches our original. So the factors are 6x plus 1 and 1x minus 2. So remember, you are using the guess and check method to solve these. Our last one is x squared minus 5x plus 12. So I'd like for you to take a little bit of time and factor this problem. So our first two terms have to multiply to equal x squared. So we have x and x are our only choices. Our last terms need to equal a positive 12. So we have 1 and 12, 2 and 6, 3 and 4. To get a positive 12 and a negative right here, I know my signs need to both be negative. So let's try these options. We get x squared minus 12x minus 1x plus 12. X squared minus 13x plus 12 does not work. So let's try x minus 2, x minus 6. X squared minus 6x minus 2x plus 12. X squared minus 8x plus 12 does not match. Our last one to try is x minus 3, x minus 4, x squared minus 4x minus 3x plus 12 is x squared minus 7x plus 12, and that does not work as well. So there are trinomials that are not factorable. So if you get a trinomial that is not factorable like this, you would write that it is prime. There is nothing that we can multiply together to get back to x squared minus 5x plus 12. You can now complete your day 9 worksheet.